Good afternoon, everyone. Today we're going to find the derivative f of x if f of x is sine x, and we're going to do so using the definition of the derivative to kind of see where, maybe the derivatives that we take for granted originally comes from. So, first off, let's start off by defining our definition of the derivative. That is the limit as h approaches 0 of f of x plus h minus f of x all over h, right? Now, let's plug in the specific function that we have, namely f of x is sine x. So we have the limit as h goes to 0 of sine of, again, replacing x with x plus h. So we have sine of x plus h minus sine of x, right? Minus f of x, and all of that over h. So now, if you remember back to some previous math class you took, we have a sum of angle identity for sine of something plus something. So sine of x plus h is sine of x times cos of h plus, reverse that, sine of h times cos of x. And then we still have minus sine x all over h. Okay? Again, that's just an identity. You can look it up on the internet, anywhere you want, if it's slipped around. Now, let's go ahead and evaluate this limit however we can. So we have the limit as h goes to 0 of, now, you'll notice that we have a sine x in the first term here, and a sine x trailing at the end. We can factor that out, so we can have sine x times cos of h minus 1 to capture both terms, right? And then we still have the sine of h times cos of x part, again, all over h, okay? Now, we know that the limit of the sum of functions can be written as the sum of the limits, right? So I'm going to write this as two separate limits. I write this as the limit as h goes to 0 of sine of x times, pardon me, cos of h minus 1 all over h plus the limit as h goes to 0 of sine of h cos of x over h, okay? Now, this first part, okay, the limit as h goes to 0 of sine x bracket cos of h minus 1, the sine x is multiplying through up front, and sine of x has nothing to do with the h, which is the variable that our limit is based on. So we can pull that sine x out front. So we can write this as sine x times the limit as h goes to 0 of cos of h minus 1 all over h. And then we can put forth a similar argument with the limit as h goes to 0 of sine of h times cos of x, because again, cos of x is the cos of a variable that is not at all the variable that we're using inside the limit. So that cos of x part can pop out front, because it's kind of like a constant in relation to the variable that the limit is speaking for, let's say. So let's pull that cos x out front, and now again, because the variable x is not the variable h, which is what the limit is evaluating for, okay? So now we have the limit as h goes to 0 of simply sine of h over h, okay? Now, here comes a bit of a tricky part. We have sine of x times this limit, namely the limit as h goes to 0 of cos of h minus 1 over h, right? Now you know that as h goes to 0, cos of h, which would go towards the cos of 0, would go to 1, right? That would mean that our numerator, as h goes to 0, would go towards 0. And so too would our denominator, right? So this would head towards 0 over 0 kind of thing, right? Now we have other tools to deal with that. You can look up this limit online, and you'll find that this limit, if you evaluate this limit on Wolfram Alpha or any other computer software that you want to use to evaluate limits for you, this limit goes to 0, okay? For now, the details are not super important, but this limit goes to 0, okay? And now the second part, we're gonna get cos of x times this limit, okay? This is a funky limit that you'll probably see later on in your math course, but the limit as h goes to 0 of sine of h over h. Now if you can think about that, this is another case of as h goes to 0, the numerator would head towards the sine of 0, which itself is 0. And so too would our denominator, right? As h goes to 0, obviously our denominator h goes to 0. So this is another 0 over 0 kind of thing, but this is such a particular function that they go to 0 at a very, very similar rate. And it turns out that, again, if you evaluate this limit on some computer software, you're going to find that this limit goes to 1. Okay, it's a unique limit in that sense. You'll most likely study it later on in a math course, but for now, you have to take my word for it. So this limit goes to 1, and so we end up with cos of x times the result of this limit, which is 1. And so now, our very last line, we get sine of x times 0, so that completely goes away, and all we have left is cos of x times 1, and so our derivative, f prime of x, is equal to cos of x. And for those of you that have already studied this, you know that the derivative of sine x is in fact cos x. So there we go. Just another application of the definition of the derivative. This one hinges on a few tricky results as far as limits are concerned, but something you'll see eventually. So I hope this helps. Thanks for watching. Take care.